All right, welcome back everyone. We have 8.2, the unit circle. Now your learning goal is to identify trig values on the unit circle, and we're really gonna do a lot of work with the unit circle, how we get these values, what it really means, connecting the dots. So we're gonna do a little bit more than this, okay? But this is your goal. So we're gonna start off with a refresher here on radian and degree nomenclature, okay? So every angle that you see, we've been referencing them with degrees, right? So this is 30 degrees, okay? However, every degree that you see can also be expressed in terms of radians, right? And a radian is a unit of an angle that uses pi to measure the arc length that the angle makes, okay? And what you'll notice is that a circle, let's see if this will, boom, a circle, we know is 360 degrees. But if I wanted to put this in terms of radian, that would be 2 pi. And it would be the same thing as 360 degrees. Okay? Now, what is a coterminal? Two angles are coterminal if they have a common terminal side. Okay? That would be this point right here. So this is 30 degrees, yeah. But a lot of the times we need to reference that 30 degrees and go, well, wait a minute. There is another part of that angle, right? There is this 150 degrees that gives us a circle. And what you're going to see with the unit circle is that this 150 degrees and this 30 degrees can be the same value because they're both pointing to this coterminal right here. Now that might be kind of confusing, okay? But let me put it in a different perspective, okay? If we're working with a circle again, okay, and I want to find, let's say this is 0 degrees here, and I want to find what this is, this 330 degrees, okay? Well, instead of just working with that 330 degrees, wouldn't this little slice right here, if this is 330, wouldn't this be then negative 30 degrees? Because it's coming down from this point instead of going around like this, and they're both meeting here, right? So you'll notice that we can use either negative 30 here, or we can use 330 degrees, okay? And that point right here is the coterminal, okay? Or excuse me, those two are coterminal because they have that common terminal side, okay? All right, now let's get into the ratio conversion, right? Because if we can use radians or degrees, we need to be able to convert between these. Now on the last slide, you saw that I said that a circle was 360 degrees and that was also the same thing as 2 pi. So that means we can sit here, in fact, let's do this above before we can convert. We can leverage that ratio, 360 degrees and 2 pi are the same thing, which means this is the same thing as 1 over 1, okay? Now, I know that part might be kind of confusing, but if you ever change, sometimes we change an equation by multiplying by -1, which doesn't really change the value, it just changes what it looks like. That's what it's going to be like when we multiply by 360 over 2 pi, or by 2 pi over 360. We can multiply either degrees or radians by these values, which is kind of the same thing as multiplying by 1, and convert them. Now you're probably noticing that both of these could be simplified, so we could also sit here and say this is 180 over pi, or pi over 180. Okay, now which one do you use to convert? Okay, well, if you're trying to go from degrees to radians, okay, you're going to multiply by pi over 180, okay? And the reason why you're going to multiply by pi over 180 is if you have 60 degrees, let's say, that's on top, right? Well, when you multiply this across, you get 60 degrees times pi over 180 degrees, meaning that that unit degrees cancels out. Degrees go away, and I'm left with, see, 60 over 180 can be converted to 1/3 pi, or just pi over 3, which is the same thing as 1/3 pi, okay? You need to kind of get your degrees across or above so that they cancel out and you're left with just the pi. And that's why it's the exact opposite if you're going from radians. if I have 2 pi as my radians, I need to multiply by 180 over pi so that my pi gets on top of each other and cancels out. Pi over pi goes away. 2 times 180 degrees is 360. And if you think about this, this makes sense, right? 2 pi is what we said was equal to 360 degrees. And when I multiply by 180 over pi, I was left with 360 degrees. Sorry, this should have been a degree right there. Okay? So this is how we go back and forth between them. And you need to know that if you are going to do calculations with radians, you need to put your calculator into radian mode. Okay? If you're going to do it with degrees, you need to put it into degree mode. Okay? Now, just to show that really quickly, if I pull this calculator up, you could see right there, it says degree, and I just should be able to, yeah, I double click it here. Oh, I single click it, and now it's on radian. Click it again, it's on degree. That's for this calculator. A lot of the times you might see a button somewhere around here or something, but there will be a way to convert that, okay? All right. Here's your first example. Let's convert these degrees to radians. I will do 2. I know I kind of just did 2, and I'll have you guys do 2. So if we have 30, we need to multiply by pi over 180, okay? Because those degrees are going to cancel out. And then I need to simplify. This 30 over this 180, I know that 3 goes into 18 6 times. And so this is the same thing as, or 30 can go into 80 6 times. 30 goes into 31. It's the same thing as pi over 6. Now you might be tempted to go 1/6 pi, but 1 times pi is just pi, and I would write it this way. There's nothing wrong with this, okay, with the 1/6 times pi, but you're going to see that for brevity, it's easier to write it this way, and when we get to the unit circle, you're going to see it as pi over 6, not 1/6 times pi, okay? Now the next one is pi over 4, all right? Here, this is the opposite way. We need to multiply this by 180 times pi. Now notice immediately, pi over pi cancels, and you're left with 180 over 4. Now we need to divide that out, and we can, you know, do this quickly. We could do this a while, but I can see really quickly that 2 goes into both of those. And so that becomes 90 over 2, and 90 divided by 2 should give me 45 degrees, okay? Now, hopefully you're getting this. I want you guys to try the next 2. Take this, convert it to radians. Take this, convert it to degrees. Why don't you go ahead and pause it and give it a try. All right, so hopefully you gave that a try. All right, you have 135 degrees, and you are going to want to multiply this by pi over 180, okay? Your degrees cancel. You get 135 pi over 180. Now, obviously, that needs to be reduced, okay? Now, you could do this by hand. You could do this by a calculator, all right? But I'm noticing very quickly 5 goes into both of these. Now, you could probably think of a bigger number also, but let's go with 5, okay? So 5 can go into 120 a lot of times. Let's think about that. 120, so that would be, what, 30 times? 5 times 30? 20 times? 25 times? Oh boy. All right, let's bust out our calculator here. All right, it's Monday morning. So we got 135. Let's do that. 135. Come on, calculator. Divided by 5. And we get 27. Okay, so I was off. All right. And then we want to do 180 divided by 5. 36. And so we get 27 over 36. Now you're probably noticing that 9 can go into both of those. So we get, what, 9 goes in 27 3 times, into 36 4 times. So we get 3/4 pi, or 3 pi divided by 4. Either one is fine, okay? And that would be your answer, all right? Now, when I got here, you know, sometimes it's easy to think about those things. Sometimes it's not. You know, sometimes we got to rely on our tools, okay? Now, 2 pi divided by 5, we need to multiply by the 180 over pi because we're going to degrees. Now, did it say we're going to degrees? No, but you can infer that because it's already in radians. Okay, those pi's should cancel. 2 times 180 is 360. And then we have 360 divided by 5. Okay, now I'm going to just put this into the calculator. 360 divided by 5. And we get 72. So that's 72 degrees. Okay, so hopefully you guys got this one. All right, if not, that's okay. But we're going to go on to a little bit more kind of building knowledge here, okay? All right, so here we have a unit circle, and this is really kind of getting into what we're working on, all right? Now, with this unit circle in class, we would have normally sat there and we would have broke this down. We would have built it from scratch. That would be really boring in a video, okay? Because it relies on a lot of your input, and then I would just be answering all the questions like, oh, well, if this means this and that means this, you know. So I kind of decided this year I'm just going to give you the unit circle and tell you, just tell you what it means, okay? All right, so here we have the unit circle, okay? And we have our degrees on the inside, and we have our radians right here. So you can see that 30 degrees and pi over 6 are the same thing. 45 degrees and pi over 4, same thing. Okay. Now, even if I said negative 30 degrees, right, going this way, that's the same thing as positive 330 degrees because we read our unit circle counterclockwise. So think about what's shorter to get to if I said 330 degrees or if I said negative 30 degrees. So if you see that, if I say like, hey, what's cosine of negative 30 degrees, you also need to know that that's just 330 degrees, okay? Now, what exactly is this helping us figure out? This has all of our sine, cosine, tangent, secant, cosecant, and cotangent values given these degrees. If I said, what is the sine of 30 degrees, okay? Well, you can go to your unit circle and go, well, 30 degrees here. I have 2 points. I have a square root of 3 over 2, and I have a 1/2. Well, it's the 1/2 is your answer, okay? You have to read these points as cosine, comma sine. I'm going to talk about why that is, okay? So, boom, look how easy that was. No calculator needed. Sine of 30 degrees is 1/2. That means sine of 45 is the square root of 2 over 2. Sine of 60 is the square root of 3 over 2. Sine of 90 is 1, okay? Sine of 120, you see this theme? It's just all the y values for sine. For cosine, it's all the x values. So the square root of 3 over 2, square root of 2 over 2, 1 over 2, boom, 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 boom. Now notice something about all these numbers, right? We have square root of 60 is 1/2, square root of 120 is negative 1/2, right? Like we're seeing the same exact numbers in different patterns, right? We're seeing, look at this, square root of 3 over 2, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, 1/2, 1/2, okay? So we have all the same numbers, it's just they're in different quadrants, and so we have different combinations of positive and negative ordered pairs, okay? Now, let's break this down a little bit further, okay? If you notice here, right, our outer points here all have 1 in them. That means that your radius and all of these is just the value 1, okay? So how did we get all of these points? Let's look at our 45 degree mark here, okay? And if I write this out here, that's 45 degrees, okay? That means this is 90, so that's our right angle. This is 45. That's what this 45 degree means, right? We're 45 degrees up, okay? Well, if this is 45 and this is 90, this has to be 45, right? 45 degrees. Making this a equilateral triangle, but more importantly, a special right triangle. If you remember back to geometry, a 45, 45, 90 triangle gives you special information, okay? Now, we know that this value here is 1, the radius, okay? And in fact, let me draw this off to the side here a little bit. It's just too two clustered in there. We have 45, 45, 90. We have a radius of 1, right? This is our x. This is our y, because look, x, y, okay? Well, think about this. If I wanted to find out what x was equal to, right, this value right here, which also is this one, square root of 2 over 2, I wouldn't use sine, I would use cosine, right? Because the cosine of 45 degrees is equal to x divided by 1, right? Adjacent over hypotenuse, right? And if I did the sine of 45 degrees, I would get y over 1, all right? So definitely cosine has to do with x because that's your adjacent side, and y always has to do with sine because it's the opposite side from the angle every single time, okay? Now if you solve this, you get the square root of 2 over 2, and you get the square root of 2 over 2 because think about it, it's the same degree, okay? Now for the 30 degree one, you draw out the 30 degree one, it's a little bit different. You get different numbers because one is, one you're using 6 degrees for, and it's a little bit shorter, okay? But notice how they flip when you do this. When you do 60 degrees and 30 degrees, look at this. Boom, x and y flipped. Boom, x and y flipped, okay? So I know this is kind of becoming a cluster here of a lot of information, okay? Let's just clear the board here for a second, okay? Let's break this down one more time, all right? You have cosine for x, you have sine for y, okay? So if I say very quickly, what's the cosine? Sorry, my cat's going nuts over here. What's the cosine of 30 degrees? Square root of 3 over 2. What's the cosine of 45? Square root of 2 over 2, okay? Now you're probably noticing something. Where's sine? Or excuse me, where's tangent? Where's secant? Where's cosecant, right? So tangent, let's go to this one over here. Sorry, we're gonna skip special right triangles because we just kind of talked about it there, right? If you think about this, right, if cosine is x and sine is y, right, your tangent has to be sine over cosine, okay, or y over x, okay? Now let's go back and let's think about that for a second here. If we have our triangle here again, right, your tangent is opposite over adjacent. Well, we said sine was for x, cosine was for, sine was for y, cosine was for x, so y over x, okay? Opposite is y over adjacent, which is x, okay? So to find your tangent value here, you simply have to do sine over cosine. So if I said, what's tan of 30 degrees, all right? Y over x. So 1/2 divided by the square root of 3 over 2. Okay, so if I write that sideways, 1/2 divided by the square root of 3 over 2. Keep change flip. 1/2 times 2 over the square root of 3. 2's cancel. I get 1 over the square root of 3. However, you cannot leave a square root in the denominator's place. So I need to multiply by the square root of 3 over the square root of 3. Okay, and this becomes the square root of 3 over 3, because the square root of 3 times square root of 3 is just 3. Okay, so tangent of 30 is the square root of 3 over 3. All right, now the sine and cosine, a lot easier to figure out, right? For tangent, you're going to have to do sine over cosine each time, sine over cosine, and you're going to have to evaluate. All right, now that still didn't answer what these were, secant, cosecant, cotangent. Well, if secant is the reciprocal of cosine, which is 1 over cosine, right, then your secant is just 1 over x. Your cosecant is just 1 over y, because it's 1 over sine, meaning your cotangent is not sine over cosine. Your cotangent is cosine over sine. Okay, now every time I give you degrees from this point on, if I give you 30, 45, 60, 90, and then all the other degrees in the unit circle, you can, if you remember this, you could just look at the unit circle and get those answers. Okay, now let's actually get into that. So we got our unit circle on the right here. We got a bunch of these. So I'll do 3 of these. Ooh boy, maybe I'll just do 4 of them, and I'll have you guys do the last 2. Okay, so sine of 225 degrees. All right, I want to know what the sine of 225 degrees is using the unit circle. Okay, so I remember a couple things here. I'm going to kind of reference my stuff. Sine is the same thing as y. As you're probably figuring out, this page right here is super important to have down. Okay, so if sine is the same thing as y, I go to 225 degrees. I look at my y value. It's negative square root of 2 over 2. So boom. Negative square root of 2 over 2 is the answer. Cosine of 11 pi over 6. So I go down here. 11 pi over 6. Okay. Cosine is x. Square root of 3 over 2. Boom. Square root of 3 over 2. Boom. Tan of 30. Okay. Now, tan of 30, well, you know what? We just did that one, right? When I was showing what tangent was, we had to put 1/2 divided by the square root of 3 over 2. We've already done that work, so I'm not gonna duplicate that work, but we got square root of 3 over 3 for that. So really hope there was no errors in that one, right? So square root of 3 over 3. Now, secant of 5 pi over 3. Okay, so we're still going to go to 5 pi over 3, all right, which we see is here, 5 pi over 3 at 300 degrees, okay? And we know that secant is the opposite of cosine, so I'm going to pull the cosine one of 1/2, okay? But it's 1 over cosine, so it's 1 over 1/2. And 1 divided by 1/2 is just 2. So that's my answer. Now, if you're confused by how I got this, keep change, flip it, and you should get 2. All right. Now, I want you guys to pause, give this a try. Try the cosecant of 225 and the cotangent of pi. So pause it, give it a try, and then I'll go over it. Okay. So cosecant of 225. Okay. So we go to our 225. It's right here. Zoom in on our unit circle here. 225. And cosecant is the opposite of sine, so I need to pull the sine. That's square root of 2 over 2. Or negative square root of 2 over 2, but it's 1 over that. So it's 1 over negative square root of 2 over 2. Okay? Yeah, 1 over, yep, okay. But we can't leave it like that, right? So we need to do some work here. So that's 1 divided by negative square root of 2 over 2, which keep change flip turns it to 1 times, let's put that over 1, negative square root of 2. We obviously cannot leave it like that, okay? But let's simplify this. We end up with, let's bring this negative to the outside here, 2 over the square root of 2. So we rationalize it. We multiply by the square root of 2 over square root of 2. And we end up getting negative 2 times the square root of 2 over 2. You probably notice that those 2's can cancel. And so we just get negative square root of 2, okay? So a lot of work for this one. That's okay, all right? But you should have gotten the square root of 2. Now, cotangent of pi, all right? Remember, cotangent is the opposite of tangent. If tangent, back here, is sine over cosine, then cotangent is cosine over sine, okay? So when I go cotangent of pi, that's right here, all right? I need cosine over sine. Well, cosine is my x value, which is just negative 1. Sine is my y value of 0. Now, you're probably noticing an issue here, okay? That would be undefined, right? And that kind of makes a little bit of sense because you can't really have a triangle there, right? For an x and y. So, yeah, okay. So, hopefully you're seeing that undefined aspect there, right? If you think about it, we try to draw a triangle. There is, like, for all these other angles, we have triangles. Well, there is no triangle when we're on there. So this is undefined. Okay? Can't divide by 0. All right. And that's going to happen, and that's all right. So in hindsight, shouldn't have left those 2 to be the most difficult ones for you guys to do, Monday morning. All right? Now, a little bit of math talk here. This lesson kind of felt like it was all over the place, all right? Again, I'm so much more used to let's build the unit circle together instead of just going, here it is. But I hope you understand the unit circle and its place. And if not, I have a couple things that I could show you in class to help you figure it out. Okay. All right, you guys. I hope you enjoyed it. I hope you learned something, and I'll see you guys next time.